My dear friend, in today's video I will discuss the lecture of analogous system, that is belongs to control system engineering. In my last lecture already I have discussed the mathematical modeling of physical system. So in today's video let us start what is called analogous system. So in today's topic is analogous system. So before we proceed, what is called analogous system, first we should know about the analogous system. So let us consider more than one system. For example, our electrical system and mechanical translational system or rotational system or gear train, like that there are so many types of systems are there. So to understand the analogous system, let us consider one electrical system and mechanical translational system. So let us first know what is called analogous system. So analogous system means that is systems whose differential equations are of identical form. It means if we will consider more than one system, if their differential equations are in identical form, then we can say that those two systems are analogous system. So to understand this, let us discuss one electrical system first. So let us first you should know what is called analogous system. The systems whose differential equations are of identical in form, those are called analogous system. So generally this analogous system is very useful in the research work, and also we can calculate the mechanical translational system by help of electrical circuit theory using analogous system. So let us take a simple example of analogous system, that is electrical system. Let us consider one electrical system that is LRC series circuit. So let us consider a electrical circuit. The input is E and LRC, that is inductor, resistor and capacitor, are connected in series. So first we have to find out what is the mathematical equation for this circuit. So by applying Kirchhoff's voltage law, we can find out what is the mathematical equation for this circuit by Kirchhoff's voltage law or KVL, we can find out the mathematical equation E is equal to L di by dt plus Ri plus 1 by C integration of I dt. So this is the voltage equation for this circuit. So now let us find out what is the charge equation. That is, if we replace I by electrical charge, then we can find out the charge equation. That is, already we know that I is equal to dq by dt and integration of I dt is equal to q. So if we put this I is equal to dq by dt and I dt of integration is equal to q in this equation, then we can find out one differential equation for this electrical circuit, and this is called mathematical modeling or physical modeling of this electrical circuit. So by putting I is equal to dq by dt, so we can find out E is equal to L d square q by dt square plus R dq by dt plus 1 by C q. So this is the differential equation for simple electrical LRC circuit connected in series. So now let us take one example of mechanical translational system. So let us consider mechanical translational system. This system already I have explained in my last lecture details about the mechanical translational system. This is having three basic elements: one spring, then one damper, then one mass, that is spring, mass, damper system. So this is the applied force F, and due to this force the displacement is x. So this is the damping coefficient and this is the spring stiffness. Therefore already we have find out one differential equation for this system, that is F is equal to md square x by dt square plus b x plus b dx by dt plus kx. Therefore for both the system we can find out two differential equations, that is one is F is equal to this much, and for electrical system E is equal to L d square q by dt square plus R dq by dt plus 1 by cq. So already I told what is called analogous system. If the differential equation of two systems are in identical forms, then we can say those two systems are analogous to each other. For example, this is a second order differential equation and it is in descending in order. This is also a second order differential equation and it is also in descending in order. Therefore we can find out the force voltage analogy between electrical and mechanical translational system. It means the force is analogous to voltage, and here mass is analogous to inductance, and here B is analogous to R, and here Q is analogous to 1 by C. K is analogous to 1 by C, and X is analogous to Q. Therefore, we can find out now the force voltage analogy between mechanical and electrical translational system. So this is your electrical system, and this is your mechanical translational system. So this is the electrical system, and the differential equation is equal to L d square Q by dt square plus R dq by dt plus 1 by C Q, and this is the mechanical translational system. And this is B, this is K, this is the mass M. So differential equation is M is equal to here the differential equation is, that is our F, input force F is equal to M d square x by dt square plus B dx by dt plus kx. So this is the two differential equations are in identical form, therefore we can find out the force voltage analogy. So here we can take voltage, here we can take force, that is voltage force or force voltage analogy. Therefore L is analogous to M here, therefore L here is M, L is analogous to M, and R is analogous to B. So R here we can analogous to B. Then in this the 1 by C is analogous to K, 1 by C is analogous to K. Similarly, here Q is analogous to displacement X, Q is analogous to displacement, Q is analogous to displacement X. So this is called force voltage analogy or voltage force analogy between electrical and mechanical translational system. So in my next lecture I will discuss details about the analogous system of different systems. So Thank you very much.